Hello, ladies and gentlemen. Root Beer with another math question. This time it comes from the 2004 Pascal. We're looking at question number 13. It's about a girl named Nadia. Nadia starts at S, over here in our picture, and walks at a steady pace once around the perimeter of a square park. Which graph best represents her distance from S as time passes? Okay. So let's just take a look at these graphs. So the time is split into sort of 4 equal chunks. If she's walking at a steady pace, I'm going to assume these equal chunks, sort of the ticks on the graph, represent where she is when she's at the points of the diamond. Okay. So she sort of walks from S up towards the top peak. And so she's steadily increasing her distance. That's fine. And this first graph, A, would seem to say that once she reaches that peak, at the top point, she stays the same distance away from S. Even though she keeps walking, she goes down to the point opposite S, she's going to be further away. We can show that. So I think we can rule A out pretty quickly. Just B, B sort of suggests that she's farther away at the top and bottom points than she is at that middle point. E suggests the same sort of thing, and D says, once again, this furthest point from S is the same distance as the top and bottom points. So really, the answer kind of has to be C, but let's look at it a bit more mathematically. So the ticks on the time axis represent where Nadia is, or when Nadia is. So we have our square diamond. Well, I can draw that a little better, can't we? So there's S over there. So these are the points represented on the graphs. Okay. So, I'm probably going to need a bigger picture of the diamond just so I can demonstrate what's going on here. So let's let, I don't know, X be the side of the square. So here's S, we know this is X. If I want to take a look at the distance here, well, it's X. Okay, no big deal there. But if now I want to calculate this distance from there to S, it's going to be straight across, it's going to be a straight diagonal. And we got X over here, we have a right angle here. So this distance is going to be the square root of X squared plus X by the Pythagorean theorem. But really that simplifies so that we got 2x squareds there. We're going to get root 2 times x. Root 2x is always bigger than x. Don't believe me? Grab your calculator out. Root 2 is bigger than 1. Root 2 times 2 is bigger than 2. So since so the graphs represent the distance Nadia is from S. And that means that the middle tick, since the ticks represent when she's at these points, should be below the highest point on the graph. And what do our graphs look like? So it's D high. This is the furthest we're ever going to get away. More importantly, it is definitely higher than these points here, which are the x's. So this would sort of have to be distance x here, and we would expect root 2x to be somewhere in the middle. So A is out. I cannot remember for the life of me what the other graphs look like. So sort of little M figure. But again, we would have x here, and this seems to suggest that root 2x is somehow less than x. So both of these graphs are out. And so I'm going to leave C to last because C is the right answer. Let's just rule out D and E, and then we'll be left with C has to be the right answer. Okay, so that's D and that's E. So D, once again, and we've got the same distance above each of these ticks, but this one should be root 2x, which should be higher. So it should be somewhere up here. So D is out, and E, sort of like a smoother version of B. Again, we have x, and this middle point should be root 2x, but that would be less than x, and that can't happen. So both of these are out. The only one that does work, the only one where our middle tick is higher, x's, only time the middle is further away is this root 2x here. And this can even make sense. We can read this graph off by just tracing out Nadia's journey. Okay. So yeah, she's constantly walking away from S at this point. Then she starts walking back a little bit towards S in the y direction, but further away from S in the x direction. With a standard x and y here. That looks like two x's. Standard x and y. Okay, but ultimately what happens is, if we take a look at the triangle, this distance here has got to be a little less than x plus a little bit more. But as we keep going, we get further and further. As Nadia keeps going, we get further and further until we're all the way up to root 2x. Okay, and all these distances here have to be bigger than x. And then we start coming back, and we all the graphs are symmetric, but we start coming back and coming back, and then we get a constant walk back. Whereas these ones here, there's a little the x is fighting to go further away, the y is going to trying to get closer, and that's why we get a curve rather than just something you might expect would be something like a peak up and down. Okay. So we sort of looked at it a little more in depth, or we can just rule out right away, looking at those points, those peaks, that C has got to be our answer. Okay. So that does it for question number 13, and in the next video, we're going to take care of question number 14. Thanks for watching.